Welcome to Spring LIB.
I will provide a two-column proof here where you can prove a variety of ways, but in this case we're given that RS and TV bisect each other at point X. What would that mean? If they bisect each other, that would mean that XT, I'll say XR is congruent to XS, and XT is congruent to V. TX would be congruent to XV by the definition of midpoint, because, well, actually by the definition of bisect, because these are bisecting each other, which means X is cutting each segment into congruent parts. I'm going to say the definition of bisect. Now we have vertical angles that are congruent as well. Angle TXR would be congruent to angle VXS. That's the vertical angles congruence theorem. You may call it something different, but it has to do with them being vertical angles. And then the triangles are congruent. Triangle TXR is congruent to triangle VXS. And that would be by two sides in the included angle, side angle side. Then, if these triangles are congruent, our goals show that TR and SV are parallel. Well, angle R would be congruent to angle S. And that would be by CPCTC, which is saying the corresponding parts, which these angles are congruent because we just said the triangles are congruent. And then this would tell us that TR and SV are parallel because we have alternate interior angles congruent with the transversal RS. So I'm going to say, depending on your textbook, a lot of textbooks will say something like the alternate interior angles converse, but double check to what your text says about this theorem.